Hello, welcome to Dr. Tinkerer's Towers of Hanoi. I'm Dr. Tinkerer. In 1989, I wanted to build a robot that would solve a puzzle on its own. My objective was to create a robot to solve the Towers of Hanoi puzzle by detecting the number of discs, calculating the number of moves required to solve the puzzle, and then moving the discs accordingly. In order to move the discs between the three positions, the robot must be able to move them both horizontally and vertically, and it must be able to solve the puzzle for up to 8 discs. The program can solve the puzzle for an infinite number of discs. However, the mechanical size and speed of the robot limits its disc capacity. For the horizontal and vertical movement, I chose a surplus Model 43 teletypewriter. It has a horizontal lead screw and stepper motor assembly that drives the printhead horizontally from end to end. Here's a picture of a Model 43 teletypewriter. I stripped it down and discarded the case, printhead, keyboard, and anything else I didn't need. I used the metal frame inside, the 40-volt stepper motor and lead screw assembly, and the power supply. I also removed the circuit board and cut it down on a table saw so I could use just the stepper motor driver circuit. Now, let's take a look at my finished robot. Here's the robot with 8 color discs stacked at position A. The stationary base of the robot houses the mechanical, electrical, and electronic components of the robot. The tower moves horizontally from stacking position to stacking position. The robot arm moves up and down on a chain and sprocket assembly and provides lifting capability. There are 3 stacking positions, A, B, and C, for stacking discs correctly while solving the puzzle. The horizontal stepper motor is located inside the stationary base and drives the lead screw, moving the tower back and forth horizontally. The vertical stepper motor is located at the top of the tower and drives the chain and sprocket assembly, moving the robot arm up and down. The vertical drive chain loops around sprockets at the top and bottom of the tower. The upper sprocket and the gear assembly are located inside the gearbox. Here's a look at the upper gear assembly. At the right is the Airpax 24-volt stepper motor that moves the robot arm up and down. The lower chain and sprocket assembly is shown here. The sprocket axle is adjustable vertically to ensure smooth operation of the robot arm. The robot needs a brain to calculate moves and control the robot arm. I chose an Intel 8086 microprocessor for the brain function. Solving the puzzle requires calculating each move and then executing that move. We'll see an example in a moment. To simplify the program, I used recursion to calculate each move as it is made. That allows the robot to use the same program whether moving 1 disc or 8 discs. The robot is programmed in Borland Pascal. To calculate the number of moves for a given number of discs, use the formula 2 raised to the number of discs minus 1 equals the number of moves. As an example, to move 1 disc, raise 2 to the power of 1 and subtract 1. 2 raised to the power of 1 equals 2. Minus 1 equals 1. It takes 1 move. Another example, to move 4 discs, multiply 2 times 2 times 2 times 2, which equals 16. Subtract 1, it equals 15. It takes 15 moves to move 4 discs. Now let's watch the robot in action. I've placed 1 red disc at A. Next, we'll move 3 discs. That requires 7 moves. Again, the robot detects the discs, then calculates and executes each move. Let's try 6 discs. That's 63 moves. This time the robot detects 6 discs and calculates and executes the first move, then the second, and so on until all moves have been made. Because a Model 43 teletypewriter originally worked at 150 or 300 baud, the robot moves slowly. Today's printers are much faster electrically and mechanically. For this reason, this part of the video has been sped up. And that's Dr. Tinkerer's Towers of Hanoi robot. I hope you enjoyed it. I'm Dr. Tinkerer. Thank you for watching.